Alright, this is section 3.2 again for the beginning algebra class. Talking about basic percent. All those videos were taken before, but now we're talking about uniform motion and kind of analyzing uniform motion problems. So I'm going to fast forward through all the basic percent stuff in my presentation and say, well, here are a couple of uniform motion problems. And uniform motion problems are going to require us to analyze units. So that'll be really helpful. Unit analysis is going to be really helpful. Uniform motion basically talks about anything that's, kind of going in one direction at the same speed. Nothing really changes. You got to have the same speed, same direction. And if that's true, like a canoeist, like an airplane, like two cars, things like that, you assume that their distance is always going to stay the same and the rate's going to stay the same. But here's our formula. It's called, I call it the DIRT formula. We got distance equals rate times time. If you think about dirt, well, there we go. I is replaced with the equal sign. Don't tell Apple that because they'll probably want to trademark that or something. But here's our dirt formula. Distance equals rate times time. So let's use that distance equals rate times time formula to maybe modify some things as well. Because sometimes we might need to solve for rate or time. So if we start with distance equals rate times time, and I want to solve for example, I want to solve for rate. Divide by time, divide by time. We can do that. It's just like dividing by a number. So on the left, I'd have distance over time equals the time over here on the right side cancels out. Time divided by time is just 1. So just like numbers canceling out, reducing, factoring out, simplifying, they do the same. So on the right side, there's my rate. If I want to also solve for time, I'd start with the same thing. Distance equals rate times time. Divide by rate this time. Divide by rate this time. Rates on the right side cancel out. I'd have time on the right side equals distance over rate. And we have to assume that all the units here in all these equations are going to be the same. But here's three different, same equation in three different forms. Distance equals rate times time, or rate equals distance divided by time, or time equals distance divided by rate. So if we're solving for any one of these, distance or rate or time, we can always start with that DIRT equation and modify it to get here. So let's use the blue box or the blue equation or the green equation to solve one of these. Let's go down here. A jogger runs 3 miles. 3 miles, that would be distance. In 45 minutes, that would be time. What is the rate of the jogger in miles per hour? Oops. All right. Well, you know what? What is the rate? All right. We need to know kind of what we're solving for. So here's my rate equation. We can start with my DIRT equation, but we can also modify it and remember that rate equals distance over time. All right. So rate equals distance over time. We could get there by modifying my DIRT equation as well, but rate equals distance over time. So let's put down rate equals distance. What's my distance? 3, and here I would suggest putting in miles. Over time, 45 minutes. Alright, but I want miles per hour. This is going to be miles per minute. If I look at my units, it's miles per minute that I've been given. Miles per minute. So I've got to modify this to get, let's see, to get miles per hour. I'm going to erase that. I want miles per hour. I got miles per minute, so what do I have to do? I got to multiply by something. I got to multiply by, let's say, minutes, some conversion factor, minutes per hour. Because what I want down here in the bottom is hours. What I have is minutes. I got to convert minutes to hours. So I need a conversion factor of minutes to hours, and I know that 1 hour is 60 minutes. So here in the green, this fraction here, I'm converting minutes to hours. 1 hour is 60 minutes. I'm essentially multiplying by 1 here. But with the unit analysis, the nice thing about the unit analysis is that it allows us to say minutes divided by minutes, or minutes divided by minutes is 1. That goes away. So what's left over? Miles in my numerator, hours in my denominator, and I'm done. And all I do now is take my numbers, write out my numbers as 3 times 60 over 45, and that'll give me my number. So all I do is just multiply 3 times 60 divided by 45 equals 4. That is my 4 miles per hour. It was going to be 3 divided by 45 would not give us the correct answer because we're looking for miles per hour. That would have given us miles per minute. So there's an example. Take a look at another one. Let's see, two cars start from the same point, move in opposite directions. Let's see, I'm going to do this here, blue. Car moving west is traveling at 45 miles per hour. So here's my north, here's my south, there's my east, there's my west. I got a guy starting here, going this way, traveling at 45 miles per hour. I'm going to go here and say car moving east is traveling at 60 miles per hour. He's starting the same spot, he's traveling east, 60 miles per hour. I'll make his arrow a little bit bigger, 60 miles per hour. In how many hours will the car, in how many hours, we're looking for time equals, will the cars be 210 miles apart? Okay, well, you know what, let's start with our dirt equation. D equals R times T, and we're going to solve for T. Divide by R, D over R equals T. I'm solving for T. Oops. Divide by R. That's right, looks like a T. Sorry, R's cancel out. T equals D over R. So I'm going to start with T equals D over R. All right, my time is my distance over my rate. All right, let's see. Time, we don't know, equals distance. Let's see. It says how they're going to be, in how many hours will the cars be 210 miles apart? So 210 miles. And my rate. Well, let's see. What I'm going to think is that, you know what, this blue guy on the left going west is going 45 miles per hour. This green guy on the right is going 60 miles per hour. Why don't we say that this 45 mile per hour guy is just waiting here and pretend that the green guy is going 205, in other words, 105 miles per hour to the east. If we think that this guy is standing still, if the green guy is going 105 miles per hour, that would be the same idea, that instead of moving apart at 45 miles per hour plus 60 miles per hour, maybe the green guy is going 105 miles per hour that way. So I'll put this down here, 105 miles per hour. And our time then becomes 210 divided by 105 becomes 2. Miles divided by miles per hour, well, let's see, if we go here, miles divided by miles per hour is the same as miles times the reciprocal of this, hours per mile. And we can say that this is over 1. Miles cancel out, and we've got hours, so here we've got hours. 2 hours. My answer is 2 hours. The trick here is considering that both these guys, instead of traveling, one guy going 45 miles per hour, one guy going 60 miles per hour, that they're going in opposite directions. You can just add up their speeds and say that is the relative speed of one versus the other. In other words, the blue guy is sitting here standing still, and the other guy's going 105 miles per hour the other direction. That's why you can kind of look at it as a different approach to it.